Hello everyone, good evening. I hope all of you are good and I am also fine. So today I will take another class from chemistry, that is from thermodynamics. Okay, thermodynamics. So our first question is an ideal gas expands isothermally from 10 to the minus 3 meter cube to 10 to the minus 2 meter cube at 300 K. Okay, so what is given here? Given T equal to 300 K and B1 is what, sir? 10 to the minus 3 meter cube. This one is volume. Okay, this one is initial volume and this one is final volume. This one is final volume. Okay, and this one is temperature. So B2 will 10 to the minus 2 meter cube against a constant pressure of 10 to the 5. So P is given here, constant pressure, that is external pressure, is 10 to the 5. Okay, so there is a formula for work done. So for work done, there is a formula. Work done is equal W equal to minus PEXT, external pressure, B2 minus B1. Okay, for isothermal process. For isothermal process. Okay, so B is 10 to the power 5, B2 is 10 to the power minus 2, and B1 is 10 to the power minus 3. If I would take 10 to the power minus 2 as common, 10 to the power 5, that is 10 to the minus 2 as common, it will be 1 minus 1 by 10 to the power minus 1. Okay, so it will be 10 to the power 3 and it will be 1 minus 1 by 10. So 10 to the power 3, it will be 10 minus 1 by 10. Okay, so work done equal to minus 10 to the power 3. If I cut this, it will be 10 to the power 2. So 10 to the 2 into 9. So minus 900 joule will be the work done. Okay, minus 900 joule will be the work done of the process, isothermal process. Okay, so let me explain it shortly again. So an ideal gas expand isothermally. Okay, that is PB equal to constant. Here this one is B1 and this one is B2. At temperature T constant, we all know that in isothermal process temperature remains constant. So temperature is given, B1 is given, B2 is given against a constant pressure. This pressure is external pressure, that is 10 to the 5 Newton per meter square. Now we have to find out the work done is what. Okay, so 4 option is given, which option is correct, we have to find out. So here is the formula. In isothermal process, there is work done is equal to minus external pressure into B2 minus B1. Okay, I put all the values and came W equal to minus 900 joule. Okay, so this one is first question. So we move on the next question. Okay, shortly. So our next question, that is question number 2. This question is came in JEE mark. Okay, JEE mark. This question is came in JEE mark. Okay. So what is the relation? What is the value of gamma for monoatomic gas, that is ideal gas? 4 options is given. Which option is correct? We have to find out. So we have to know gamma is what. First we have to know gamma is what. I explained, right, the formulas here. Okay, formulas. I will explain every formula related to every questions. Okay, the formula uses in every questions I will explain in right side. Okay, so for gamma is what, sir? Gamma is specific heat ratio. Okay, specific heat ratio, that is Cp by Cv, where Cp is molar, what? Molar heat capacity at constant volume. Okay, and Cv is, sir, what? Molar heat capacity at constant pressure. Got my point? Okay, so gamma is Cv. For monoatomic gas, here what is the value of gamma for monoatomic gas? So you have to remember for monoatomic. Okay, monoatomic gas, for monoatomic gas Cp is 5 by 2R. R is gas constant, R is universal gas constant. Cb is 3 by 2R. Okay, so gamma will be Cp by Cv. It will be 5 by 2 or 3 by 2 or 2 to cancel, that is 5 by 3. Okay, so which option is correct here? Option D will be the correct answer. Option D will be the correct answer. So how can you have to remember this one? For monoatomic gas, Cp is 5 by 2 R. Okay, fine. Sir, for monoatomic gas, Cb is 3 by 2 R. Fine. Now the question is, I find the gamma equal to Cp by Cb, and its simplification 5 by 3 is scheme. Now, sir, for diatomic, if the question asks for diatomic, if the question asks for triatomics, then what will we have to do? How can I calculate this one? So I write here for diatomic gas. Okay, if they ask a diatomic for diatomic gas, Cp is equal to 7 by 2R and Cp is equal to what, sir? 5 by 2R. Okay, so gamma will be Cp by Cb. If we put this one, it will be 7 by 5. Okay, and for triatomic, if the question asks for triatomic gas, then what we will do? We will do here Cp is what, sir? 9 by 2R. Okay, and Cb is what, sir? 7 by 2R. Okay, fine. Therefore, gamma will be what? Cp by Cb. It will be 9 by 7. Okay, so in question they ask only for what? Monoatomic gas, but I explain for diatomic gas and triatomic gas, because of why they may ask in the question, they ask monoatomic gas, but in the coming question entrance exam they may ask for triatomic gas. Then in that case what we will do, sir? So no need to worry. I already explained for diatomic gas, Cp will be 7 by 2R, Cb equal to 5 by 2R. And for if they ask for triatomic gas, then gamma Cp will be 9 by 2R and Cb will be 7 by 2R. Okay, then you find gamma easily, Cp by Cb. Okay, so see, there is a relationship between the increase of Cp is here 5 by 2R and Cb is 3 by 2R, and here Cp is 7 by 2R. There is plus 2 here added. Okay, plus 1 is added, plus 1 is added, plus 1 is. That is for diatomic gas, Cp will be Cp for monatomic gas plus 1, is not it? And for triatomic gas, Cp will be for diatomic gas plus 1. That is, if you increase by 2, it is in AP. If you increase by 2, that is 5 by 2. Here it is 10 by 2, it is 9 by 2. Here will be 3 by 2, it will be 5 by 2, it is 7 by 2. Okay, so you have to remember this one in this way. Whatever the method you have, you remember in this way. Okay. So move on the next question. I hope it is helpful for you. Okay, so move on the next question. So students, our next question, that is question number 3, is like that. This graph expresses the various steps of the system. Okay, containing 1 mole of gas. Okay, fine. Which type of process does the system have when it moves from acid to A? Okay, there are various types of graphs are there. When we have to find out the system, we know that there are how many thermodynamic systems are there? 4 basically types are there. That is isothermal process, adiabatic process, isobaric process, and isoporic process. Okay, so which system is belongs the graph when it moves from C to A? That is, when it moves from C to A, it is belong which graph we have to find out. That is which process. Okay, it may be isobaric, it may be isoporic, it may be isothermal, or it may be cyclic. Okay. So here there is a formula. You know that there is a formula for ideal gas equation. For ideal gas equation, there is a formula. Okay, what is the formula is there? There is a one formula is there. P1 Pb equal to nRT and Pb by T equal to nR. If the number of moles is constant, if n is constant, then P1 B1 by T1 equal to P2 B2 by T2 equal to constant. Okay, we can write this one equal to what? Equal to constant. If n is constant, then r is also constant, gas constant. So this one is constant. Okay, this is from ideal gas equation. Now look at the graph expresses the various steps of the system containing 1 mole of gas. Which type of process does the system have when it moves from C to A? Okay, so now look at here, at temperature, this one is temperature, this one is volume. So at temperature T1, that is at temperature for graph C to A. Okay, suppose this one is at temperature T1. Okay, this one is final, this one is T2. At temperature T1, temperature T1, this one is T1, this one is C to A, na? So this C is initial position, this initial temperature is 600 K, and initial volume is B1 is 20 liter. Let pressure P1 is pressure. Okay, and at temperature T1, and now at temperature T2, at temperature, okay, at temperature T2 30, B1 is 10 liter and P2 is pressure. P2 is pressure. Okay, here into P2 is pressure. Okay, therefore we know that relation P1 B1 by T1 is equal to P2 B2 by T2. See, use the formula here. If you use the formula here, you will get P1 is P1, B1 is what, sir? 20, and T1 is what, sir? 600. Here P2 is P2 and B2 is what? 10, and here is 300. Okay, this one and this one will be cancelled, and this one will be cancelled. If I cut this one, this part by this, it will be 2, and 2 will be cancelled. So therefore P2 equal to P1. So P2 equal to P1. So it is which process? The name of the process is what? The name of the process is isobaric. In isobaric process, the pressure remains constant. Okay, the name of the process is isobaric. That is option B is correct. So isobaric. So in isobaric process, pressure remains constant. In isobaric process, pressure remains constant. Okay, that is del P is 0. So we have to know in isobaric process pressure remains constant, that is del P is 0. So let me explain again. This type of graphs may come in some in your exams. Okay, this question is came in AIMS. This question is came in is entrance exam. Okay, medical entrance exam before March to NEET. So there is a graph and we have to find out which process is this. 4 option is given. So I use the formula, that is ideal gas equation, PV equal to nRT. If n is number of moles is constant, there is 1. So P1 B1 equal to P2 B2 by T2. Okay, P1 B1 by T1 equal to P2 B2 by T2. This one is constant, and here at time T1, at temperature T1 volume is 20, and at temperature T2 volume is 10. Okay, that is 300. Then suppose initial pressure is P1, there is initial pressure. Okay, and this one is final. So I use this formula. After use this formula, we get P2 equal to P1. So P2 equal to P1, there is pressure remains constant. In which process? Isobaric process. So option B is the correct answer. Okay, option B is the correct answer. So let's move on the next question. Okay, let's move on the next question. So our next question, that is question number 4, is like that. 16 gram of oxygen gas expand isothermally and reversibly at 300 K from 10 decimeter cube to 100 decimeter. Sorry, 10 decimeter cube, it will be 100 decimeter cube. Okay, 10 to 100 decimeter cube. The work done in joule we have to find out. Okay, so what is given here? First I explained the formula here. Okay, the work done in isothermal process, that is work done in isothermal process. Okay, so W equal to minus 2.303 nRT log B2 by B1 or P1 by B2. Okay, log B2 by B1 is the formula, or minus 2.303 nRT log P1 by P2 in terms of pressure, here in terms of volume. Okay, so what is isothermal process? So definition, what is the definition of isothermal process? So in isothermal process, the temperature remains constant and pressure and volume will be changed. In isothermal process, what? Temperature remains constant. Okay, that is del T equal to 0. That is del T equal to 0. Therefore, we can say mathematically PB equal to constant. We know that from PB equal to nRT. Okay, we know that from ideal case equation PB equal to nRT. Okay, so T is constant, nR constant, R constant, so PB equal to constant here. So we can set P1 B1 equal to P2 B2, or we can say P1 by P2 is equal to B2 by B1. Okay, this is the isothermal process. Okay, in thermodynamics. So here you will look, this is the formula of what? Work done in isothermal process, minus 2.303 nRT log B2 by B1, or B2 by B1. If you replace this part in terms of pressure, it will be P1 by P2. Now come here, 16 gram of oxygen gas, that is mass of oxygen is given. So what is given here? Given W is equal to 16 gram oxygen gas. So oxygen gas, molecular mass of oxygen is what? Molecular oxygen mass is 32. So number of moles, N is equal to what? W by M, that is 16 by 32, that is 1 by 2. Number of moles is what? 1 by 2, that is 0.5 mole. Now temperature is given what? 300 K, and this one is temperature. Okay, and this one is initial volume and this one is final volume. Got my point? This one is initial volume, that is B1 equal to 10 decimeter cube and B2 equal to 100 decimeter cube. Okay, so we have to find out the work done. So work done in isothermal process is what? W is equal to minus 2.303 nRT log B2 by B1. Minus 2.303, N is what, sir? 1 by 2. R is what? 8.31, and T is what, sir? 300. Log B2 is what? 100 by 10. It will be 10. So minus 2.303 into 1 by 2, it will be 4. If you cut this away, 8.31, and into, if you cut this, it will be 150 log 10. Log 10 is what, sir? 1. So 2.303, 8.31, 150 into 1. So if you multiply this one, it near about comes 2872 joules. 2872 joules. Okay, it near about came 2872 joules. That is, or approximately, which option is came? If you multiply this, it will came 2872 joules. You consider here 8, here is 2, there is 16 to 150 is what? 16 to 115. You consider here 2 and here is 8, so 16 to 15 is what? So it will be 80, this one is 6, this one is 1, so 0, there is 4 and 2, okay, and 0. So it is near about which one? Near close to 2875, that is minus 2875 is the correct answer. Okay. So option B is the correct answer. Option B is the correct answer. Got my pen? So let me explain again. This is the formulas of isothermal process, work done formula, and what is isothermal process I explain here. Now this one is the questions. In the questions what is given, whatever the data given in the questions I marking as box. I including this data is in the box. Okay, this one is 16 gram oxygen. So mass of the oxygen is given 16 gram. Molecular mass is 32. Number of moles we find out, N is W by M, that is 1 by 2. Temperature is given 300 Kelvin. So B1 is what? This one is B1, this is initial volume, and this final volume is B2, 10 and 100. Now work done in isothermal process is 2.303 nRT log B2 by B1. I put all the values. After simplification came log 10. Log 10 is what? 1. So if you multiply this, it comes near about 2872 joules. That is this one. Option B is the correct answer. Okay, option B is the correct answer. So we move on the next question. Okay, we move on the next question. So our next question, that is question number 5. Calculate the work done when 1 mole of an ideal gas is compressed reversibly from 1 bar to 4 bar at constant temperature of 300 K. So here they mention constant temperature. So for, look at here, for constant temperature. So constant temperature, the process is isothermal. Okay, for isothermal process, work done is what? Minus 2.303 nRT log B2 by B1 or minus 2.303 nRT log P1 by P2. Okay, this is the formula for isothermal process. I already explained in the previous questions. Now here what is given? They given P1 is what, sir? 1 bar. P2 is, pressure P2 is 4 bar. Okay, so work done for 1. Number of moles is 1 mole. 1 mole of an ideal gas. Okay, so ideal gas. So therefore work done W equal to minus 2.303 nRT, that is R is what? 8.31. okay, nRT log P1 by P2 minus 2.303, N is what? 1, R is what? 8.31, T is what? 300 and log 1 by 4. So if you multiply this, first I convert this one, it will be 2.3 into 8.3 into 300 into log 1 minus log 4. Okay, so if I multiply this, it will be 16 and near about 18. Okay, if I multiply this near about 18 and 300, it will be log 1 is 0 and log 4 is 2 square. Log 4 value is 0.5, almost 0.5 log 2. Okay, so minus it will be plus. So 18 into 300 into 0.5. So if you multiply this, it will be 90. It is 9.0. That is 300. So 0 and 27. So near about this one and near to this. Okay, near about this one and near to this. So 2 point something. So 2 point something, that is 2 point something kilojoules. 2 point something kilojoules. Okay, 2 point something kilojoules. It will be 2 point something kilojoules. Okay, 2 points, that is 2.7 kilojoule. So this is 4.01, this is minus 8.02, and this one is 18.02 Kelvin. So none of them there. So which option is correct? Option D is the correct answer over here. Option D is the correct answer. So option D is the correct answer. Okay, I hope you got my point. So you have to calculate. First you have to understand this one is constant. Look, calculate the work done when 1 mole of gas, 1 mole is given. compress reversibly from 1 bar to double bar. That is P1 equal to this one, P2 this one. Number of moles is 1 and R is 8.31. We know that here. Now work done is what? Work done is what, sir? Work done is isothermal process. This one is constant pressure, so it is in isothermal process. For isothermal process, we know that these are the formulas of work done. So I put all the values, and after simply what becomes near about 2.7, that is 3. But there is no option is given 3 such that, so I consider this one option is D. So which option is correct, sir? D, option D is correct. Okay, I hope you understood this one.